Thank you very much for the introducing words, Professor Weigold. Welcome everyone here to this conference. I'm very happy to speak to you today and give the first keynote here. And I will try to give you an impression on how we see digitalization at GMN, what we think about it for the spindle technology or for the machine tool industry in general, and what topics are there and what we can do and must do. Yeah. So the title is How to Understand Spindles Better, and I want to give you an idea how this is possible. So let me give you one short introduction of GMN. So GMN is founded in 1908, so we have more than 100 years experience in high precision bearings, high precision spindles. It's still a family-owned business with around 450 employees. Our production is completely done in Germany, in Nuremberg, so in the south of Germany, and we have worldwide sales and services. Our key products are here on the left side. It's spindle bearings, so high precision, high speed bearings. It's the spindle technology. We have freewheel clutches and also contactless seals. So, in this presentation, I want to give you an impression on digitalization. And when I was preparing the speech, I asked myself, what are the main drivers for innovation in the machine industry today? When you go to conferences nowadays, and it started again a couple of weeks ago, I was in Aachen, and there we talked about data-driven sustainability. So how can we use data? And I looked in the papers, in the newspapers, and I found an article about trends in the machine tool industry. And when you look at these 7 trends, most of them are about digitalization. Let's pick out 4 of these 7 trends. So you can see here we have the topic of new business models. So the companies are thinking about how can we build new businesses around digitalization. Then we have the topic of digitalization in general. So how can we digitize our products? How can we make data available? How can we interoperate? How can we collaborate? Then it's about security for machines and cyber-physical systems. So also a very important topic, but again, related to digitalization. And then we have automation. Automation always is about collaboration, machine-to-machine interaction. So from 7 trends the industry is dealing with at the moment, 4 of them are directly related to digitalization. So one can say digitalization is the key driver of innovation nowadays. Yeah? It's also, as we have just seen, the research projects, most of them are about using sensors, bringing information together, bringing collaboration cross-domain. Yeah? So the machine manufacturer, the spindle manufacturer, the tool manufacturer, all the different knowledges are at different people or different companies, and we have to bring this together. And this is what digitalization is about. For us at a spindle manufacturer, the question is now, what does this mean? What does this mean for spindle technology? What is our duty now? How can we address this? And let me start with some very short example. When I went to university, we talked about the automation pyramid. We had a strict hierarchical organization of how a company works. You have field devices, sensors, and then you have the different levels within your company. Nowadays, this pyramid is transferred to a network. So the hierarchies we had in the past, they are gone. It's possible to communicate between all the different layers of a company. So a sensor can talk through the ERP system. It's not, we don't need the SPS for this anymore. So it's now possible that everything can be interconnected. And this is more or less the basis for digitalization, for new solutions, for this kind of new business models, and so on. And for us, as a spindle manufacturer, we are at the very bottom of this. We are a classical field device. We have sensors in our spindles. We are connected to the SPS, and in the past, the spindle ended at the end of the spindle. We didn't look what comes next. Yeah? Cables came out, we're connected to the SPS, and we were done with our business. Yeah? And this has changed because now we can make a connection to all the different layers. We can not only connect to the SPS, we can connect to the MES, to the ERP system, and we can even connect to different companies. We can interconnect our spindles between different facilities at different places on the globe. This is what the new technology brings to us, or what the possibilities, what possibilities are there. So what does this mean? Or I want to come back to my question. In our opinion, a spindle must be IoT ready, and it must enable digitalization. Yeah? So this is more or less the key idea, what we bring to our company and how we want to, or what we want to bring to our customer. This is our understanding of a spindle today. So let me explain to you how this can work, or how we as a spindle manufacturer can address this, how we can be IoT ready. And to explain this, I want to start at the very beginning. Yeah? At the first generation, or when we started building spindles, we built spindles with external drive. This was a pure mechanical component. Bearing, shaft, housing, done. Then we started to integrate the drive. We had motor spindles, which is common today. In these spindles, we already had some sensors. But nowadays, or state of the art, we have integrated sensor systems. So the spindle is not just a mechanical part with a motor, it also has sensors, and it does not only have sensors, but it also has microchips in it, which do interpret sensor information, which give information. Yeah? So it's integrated sensor systems. But still, this is just where we are today, and it's not really digital. Yeah? Let me give you some examples of what we have in a spindle. For example, very common, we have temperature sensors, very easy PT elements, which are in the spindle. We have acceleration sensors. We have the clamping unit. This is a good example for an integrated sensor system. Such a system has a couple of sensors, 3, 4, 5 sensors, which measure the position of the shaft, measure some other systems, and you get an information on what your clamping unit does too. Is the tool in the right position? Is there a tool in the spindle or not? So you get a real information. You don't just get the position of the shaft. The interpretation is already done in the spindle. And another example, we implement displacement sensors. So many different sensors which are in the spindle, and this is very common. All of us do this, all our competitors do this. But how does the information come, or how is the information created? And when you look at this picture, this is how spindles are connected today. So there's a multi-plug at the back of the spindle with, I don't know, 20, 25, 26 pins. And all the signals coming out of the spindles are analog or binary signals. Yeah? And these signals are brought to the machine cabinet, and then there the analog digital converter is to bring the information into the digital world, and you bring it to the field bus and you can use it. Yeah? But at the end, let me give you an example from our all-day life. This is when you are in your home office and you want to plug your mouse into your computer. This is as if you need a screwdriver to bring your mouse to your computer. This is the level the industry is at the moment. Yeah? So that's not just an USB port, you just plug it in and everything is running. You need a screwdriver and you need tools, you need to implement things. It's very, very complicated. Yeah? And in our opinion, this is not up to date anymore. There are much better solutions for this, and this is the basis for a digital spindle. So in our opinion, the next spindle has to be digital. The sensors within the spindles have to be integrated into information technology, and for this we use an embedded system we call IDEA4S. So the the AD converters are within the spindle. The information is coming to the machine cabinet in a digital format. So we utilize a serial interface to connect spindle and machine. And this makes it possible to not only bring the information from the spindle to the machine, it makes it also possible to bring information from the machine to the spindle. Why do we use IO-Link? We use IO-Link because it's a standard widely used in the industry, and in our opinion, it's the new standard for field devices, for standard sensors. When you look at the sensor manufacturers, it's often the case that IO-Link sensors are even cheaper than classical analog or digital sensors. Yeah? So this technology is coming to the market. Yeah? The nodes in the field are growing exponentially, and this gives us new opportunities. So what does our system do? At the end, it's a platform for digitalization, and the idea in the first spot is to measure information, to bring sensor information to our machine manufacturers, to the machine manufacturers, so you know what is the temperature of a bearing, what is the displacement of the shaft. At the beginning, it's just measuring. But it's also identifying, so what is the spindle I have there? What does the spindle do? What are the properties? And then how can we monitor a spindle? Yeah. Just to give you an example, what signals can be measured, it's the speed, it's the clamping unit, it's the temperature, it's the displacement, it's the vibration. So this kind of information is already there, and also the standard we have today, this is what we have today already. So the information is just analog and binary, and now it's digital. We can identify the spindle with a digital type plate, and we can also put application data into a spindle. Yeah? So what is the spindle used for? And also the machine can write this information into the spindle, and when the spindle comes back to service, you know, oh, the spindle has been mounted to this machine in this factory, and it has been used for that. Yeah? So you understand what your spindle is used for, and it makes it also possible to do something like asset tracking. Yeah? So a spindle is a very valuable component of a machine tool, and many end customers have several machines, several spindles. They have spindles in stock for repair, and if they know which spindle is in which machine at every moment, and they know which spindle is in stock, it's much easier to know where are my assets and to plan to plan everything. And at the end, we want to be a platform to monitor a spindle. We want to give a fingerprint, we want to give a status on sensor signals, so it's not just about giving the temperature information, but telling you, is the temperature okay? Yeah? And we try to bring our knowledge, our domain knowledge from us as a spindle manufacturer into this. So we try to look not only at one signal, we try to look at all signals and interconnect them. So just to give you an example, when the temperature of a spindle is 40 degrees, this doesn't tell you anything. It's very important to know what's the speed at this moment. Is the speed 60,000 RPM, or is it 30,000 RPM, or is it 10,000 RPM? What is the cooling fluid temperature? Yeah? When we have a wide range, you can use 18 degrees, but you can also use 30 degrees. This changes a lot in how to interpret the absolute temperature of a spindle. Yeah? And this is what we try to do. We give you statistics, so we know what was the maximum temperature, and we also try to monitor the process. But I will come later to this, because at the end, we as a spindle manufacturer are not able to monitor the process, because we have the vibration information, but for example, we don't know which tool is in the spindle. Yeah? And this is also what digitalization is about, and what we hopefully will talk about the next 2 days, that we have to bring the knowledge from all the different domains within a machine tool together. Yeah? So the information on the tool is somewhere else than as the information on a drive and the information of a spindle. And someone who builds a tool has more knowledge on a tool than someone who builds spindles and the other way around. So we have to bring this knowledge together, and we need a platform to utilize this to make it possible to access this information by the end customer. We have to generate value there. Just a very, very short example for a histogram. Yeah, as I was talking about, the idea is to bring different information together. And as you can see here, now this is a diagram with the rotational speed of the spindle and the temperature of the bearing. So this is the kind of information we can collect within the spindle. Yeah, so we know at which speed, at certain speed ranges, how long has the spindle been operated at a certain speed range. And we can also look at this looking on the temperature. And as I said, a temperature of 40 degrees at maximum speed is a different thing than 40 degrees at medium speed. Yeah, so you have to interconnect this information and bring it together with your knowledge about the product. So at the end, our system is first of all digitizing a spindle. It brings the analog and binary values or information of a spindle we have today into the digital world and connects it to IoT infrastructure. And as I said, for us, spindles usually ended at the cover of the back of the spindle. And nowadays, we have, with this technology, we are now connecting to the machine infrastructure, where there is the IO-Link master, which connects the information to the SPS, where it can be used as today, yeah, to monitor temperatures, vibration levels, and so on. But, and this is the very important part, in the world of IoT, it's now possible to bypass this information to the IoT world. Yeah, so the information of a sensor must not only be does not only go to the SPS, it can also go bypassed to another solution, to interconnect machines, to bring data into the cloud, to bring it to an edge device, to make remote services possible without putting performance out of the SPS. And this is the picture where you can see that collaboration is not only possible, but also necessary. Yeah? What I said, there's knowledge at different companies, and we have to bring this knowledge together to create solutions for our customers. Yeah. So what are the benefits of such a system, just to give you a few? First of all, it's a easy and robust machine integration. Yeah? And then it enables digitalization, and that's what I meant. So the system, first of all, brings the information of a spindle to the digital world. It's not in the first step creating new business models or these kind of things. It's just the start. It's just the first step. Digital information in two directions. So you can, the spindle and the machine can now talk. Yeah? This was not possible before. So it enables digitalization. It makes it possible to identify a spindle and to track a spindle. It generates transparent usage, so you know at which speed, at which temperatures, and so on. So in a case of service, you can understand better what has happened to your spindle. It makes it therefore easier to do diagnosis during service, to understand what has your spindle been doing, how has it been operated, and was this good or was it not good? It gives you a hint. Yeah? And it also makes it possible to do new warranty models. But as I said, this is just the basis. This is not really an IoT solution at the moment. It's just an analog information which is now digitized, which can be used, but we now have to do the next steps. And for this, what should be our main focus is to create customer benefits. So we really have to think about what does an end customer need. Yeah? How can we create benefits for them utilizing digital technology? So we have to find use cases where we use such a technology like IDEA4S, and create customer benefits by collaboration. So we have the spindle manufacturer has to collaborate with the machine manufacturer, has to collaborate with the tool supplier. We all have to find our ways to work together. And I think it's a change of paradigm in the industry, because in the past you bought a ball bearing, you bought a ball screw, you bought a spindle, and you put it into your machine tool and it worked. And for creating IoT solutions or to create benefits for the end customer, we have to find a way to collaborate. We have to find a solution, or we have to find a way to bring our knowledge from different domains together to create benefits for our customers. And I think this is the main goal for us in the industry. And I also think the research or academia should pick this up, because I think research can create this collaboration. It's a possibility for you to bring people together, to find use cases, to build demonstrators, to help us as an industry which comes from the mechanical world, understand how software, how this world works, and bring new ways to us to work together. And I think this would be a very nice thing. And yeah, this brings me to the end of my talk. We think we are en route to the digital spindle. We did the first step. We are now planning to do the next. And we are looking to collaborate and work with you together to start this journey into this new world. Thank you very much.